here. Of course, you open there.
Live streaming, great.
Your call is important to us. Please hold. It's connecting, it says. And I'm pretty sure I will hear myself in a second. And we were already live. Yes, I told you. So here we go. Right. Hi. So welcome back. We finally made it back. And I see 22 people online already. So this is awesome. Welcome to another virtual Kotlin user group session. And I'm so happy to have a full Zoom call. With me are not only the amazing folks from Formation, including Gilles, who will give his talk today. With me are also Randy and Julian, and these two guys are so nice to support us. Oh, now I can say us, with the virtual Kotlin user group organization. So you will see other faces than mine. You will hear other voices than mine in the future. So we will find some kind of rota or something. We have to discuss this. But I will give you, Julian, the stage first to say hello. Then people can see you as well.
Sure. I guess you guys are seeing me. So hi, I'm Julian. You might know me from the Kotlin spam on Twitter, I think. What can I say? No, I'm just, you were searching for people to help, and I'm most happy to have more content on YouTube and out there. So regarding Kotlin, so yeah, I'll be there to help you. Just looking forward more content, basically. That's it.
Great.
You there then as well. And I am hanging. I hope it's not, oh, what did I say? And also with me is Randy, as I said. So Randy, say hi.
Yeah, hi guys. Hope you can see me. So my name is Randy. I came from Cuba. I will be joining the Kotlin virtual Kotlin conf since now. Yeah, I'm here like for 3 years now, and I discovered this group. I'm ashamed of it just a few months ago. But Hoge was asking for help, and yeah, happy to jump in and contribute and share the knowledge. Yeah, hope to see you around. Yeah.
Awesome. So if any one of you was afraid that he or she has to speak with me when you want to join us online, you can now speak to the much nicer guys, Randy and Julian. And please ping us if you want to be on stage. We will help you, and we would love to have you on. And yeah, so this brings us also over to Julian's talk. As always, please feel free to use the chat, and please also leave questions in the chat. I will relay the questions to Julian and his team. And also, if you haven't done so already, press this subscribe button down there. There's also this little bell beside it. You can press it to get notifications when we schedule a new session. And with this kind of housekeeping, I will start shutting up by handing it over to you, Gilles. It's
yeah,
your stage.
Great. So this, so I'm Gilles. This on my left side is Nikki. And on my right side is Jacob, and this is essentially our entire tech team. So most of what you're going to see was built by them and by me in the last probably 2 years. And yeah, we will discuss a bit more later about our odd choices in tech and how actually awesome that is. So briefly, we are working for a company called Formation. So what is Formation? We'll show the app in a minute because it's a full stack Kotlin app and it's cool. But what do? We essentially productize location for companies. So if you go into any factory, hospital, or wherever people work that are not behind the desk, right? So what do they have in their pocket? A phone. What's on that phone that they use, things like WhatsApp and other consumer apps. So essentially the digital workplace exists in offices for white collar workers, but not really yet for blue-collar workers, and that's kind of the audience that we're targeting. So we built an app that is map-centric, that we will show in minutes, that essentially puts things like your office building or your factory floor or your hospital in a digital map and allows you to share content there. So who are we? So I played a little cheeky joke here by crossing out our actual job titles and just labeling us as full stack developers, but that's what we are. I've been doing Java, JavaScript, and most recently Kotlin for the better part of probably close to 30 years. So Java's birthday, 30th birthday is coming up in a couple of years, and that's also when I started using it. So yeah, that's it. The rest of my tech team is a bit younger than me, so but no less. So what are we gonna do? So I'm gonna briefly show some slides and try to spend most of the time actually looking at demos because it's more interesting, I think. And also we have so much stuff to demo that I will be skipping some of the basic stuff that you've probably already seen before. All of the demo code is in a Git repository that is shared at the end of this presentation. I will later share a link with Holger, and we will distribute that, I'm sure. Kind of starting at the beginning. So where is this coming from, right? So I was playing with DALL-E a little bit over the weekend, asked it the obvious question, what is full stack? And yeah, you get beautiful pictures, but generally, this is something that JavaScript developers started talking about 10 years ago, when they discovered that JavaScript does not only work in a browser anymore, but you can also do Node.js. And of course, there are lots of other software stacks available as well. So generally, full stack development is understood to be web and server, but I would say that that is a increasingly obsolete notion, and we're definitely also stepping outside of those boundaries, especially with our product, because we're also doing a lot of IoT integrations, for example. So the history of JavaScript started in 95, which is also when Java started, and I guess they already had Java running in the browser, so that was a nice name, but that's, aside from some syntactical similarities, the only relationship between the two. It actually took quite a while before it became actually useful. So until about 2000, there wasn't really much you could do with it except animate some menus and do some silly things that people did on web pages. And then it was another 5 years before we saw things like Google Maps, which I kind of mark as the start of single page applications becoming a thing. So Google Maps was amazing. I was actually at the time working with a content management system, and we were targeting Internet Explorer 6 and Netscape Communicator, whatever, 4 or something like that. It was a pain in the ass because literally every feature would either work in one or in the other, but never both, unless you jumped through a lot of hoops. And we had like one designer / UI expert whose sorry job it was to maintain all of that. Fast forward another almost 5 years, 4 years, Node.js became a thing in 2009. So that's when full stack programming suddenly became a thing. So all these people that discovered that, hey, you can also write shitty code on the servers and have the same problems there. And then it didn't take long for Microsoft to start thinking, well, this JavaScript thing, better do it properly. So basically they introduced a compiler for TypeScript. Shortly after, Webpack became a thing, which I have a love-hate relationship with. We'll talk about that later. But essentially from then on, JavaScript is just a compiler target, right? So even the JavaScript that people write is actually ECMAScript, which then typically gets minified and transformed into JavaScript. And of course, since Kotlin 1.0, 1.1, we have Kotlin.js in sort of a test mode, and probably since last year in a semi-stable form. WebAssembly is, of course, a thing, and if you pay close attention to the Kotlin release notes, you might have noticed that they forgot to tell us that they silently launched a WebAssembly compiler for Kotlin. So that is currently only working in Chrome if you have the right experimental flags turned on. But and it's probably not very useful yet, but it's coming. So that's interesting to know. Yeah, basically the monopoly that JavaScript had on browsers technically kind of ended in 2012. Because that's when we got TypeScript, and since then there's all these other languages that also compile to browser JavaScript, and of course now we have WebAssembly, so why limit ourselves? And kind of the point of this presentation is that yeah, Kotlin is actually very much a full stack language, and I would say a better one than JavaScript at this point, even though it's still got some rough edges here and there. So very quickly, I'm sure this has been covered in this meetup and others. I'm not going to spend a lot of time on restating the obvious here, but yeah, Kotlin has multiple compilation targets. The JVM is the obvious one, which is used for Android and servers. But there's also native, which is what you would use if you want to go and compile your code for iOS, for example. And actually the WebAssembler compiler is kind of building on top of that. And then there is the JavaScript Transpiler, which kind of works just like TypeScript does. It's a transpiler. It spits out JavaScript and it runs in your browser. Pretty much at this point, any place where you would use TypeScript, you can also use Kotlin. So there are people doing React applications with kotlin-js, and it just works. On the Node.js side, in theory, it's the same. In practice, it's a bit more limited, mainly because they just don't have the Kotlin type mappings for most of the Node's API. You can actually write those yourself, but yeah, it's a bit of a non-starter. The browser APIs, pretty much anything you need is mapped to Kotlin, and yeah, you can build some beautiful stuff there. And basically the message is anywhere you can get Kotlin to compile, you can use Kotlin, which is pretty much anywhere. So why did we do this? So, normally I actually advertise minimizing risk when running companies. I've been CTO in several companies, and technical risk kind of multiplies. So you pick one risky technology, you can get away with it, but you pick three, it gets bad. So this was definitely a risky move when we did it, and there was a reason. I had, at the time, we had a half-finished Android app, which was a bit of a mess, and it's kind of what I inherited when I joined the company. And we had a lot of pressure to also support web and iOS, and then our lead Android developer left, and yeah, the remaining team knew Kotlin and nothing else. I actually did some TypeScript and JavaScript in the past, and I can wing it there, but we were in a hurry to launch an app. We were not having a lot of time to learn new languages and frameworks and whatnot. And then actually in this very meetup, probably one of the first COVID ones that was online, I saw the Fritz 2 presentation. I was like very impressed. Took me a couple of months to sort of try it out. So we did an internal spike on, can this thing work at all for us? Yeah, a few weeks later, we kind of came to the conclusion, well, actually, everything we've tried so far just works. And we can kind of reuse the little multi-platform Kotlin library we already had. We can just reuse that and start building on that. And we'll kind of move forward from there, and pretty rapidly as well. So that started, I'd say, end of 2020. The first half of 2021, we kind of went from a demo to a full-blown product. And I think by the 6th month, we were kind of beyond what the Android app ever did. And since then, we've been just building it out. So at this point, I'm going to hand over to my wonderful friend, Jacob. Actually, just use the thing here. So Jacob, you want to tell us about this?
Shuffle around a little bit.
Yeah, we'll shuffle around a bit.
So, yeah, what you see is our web app at the moment. The base is a MapLibre map. You see where we put on some floor plan as a demo environment and a lot of demo content. Yeah, the main app frame here is a side menu where you see settings which are at the moment in Dutch. So yeah, we implemented a language switch, so we can switch that to English back. Yeah, and all the things you want to have, terms and conditions, inbox for notifications which come in via the WebSocket from other users that changed objects or invite you to a meeting, which leads me to the basic functions you can do. You can create content via this menu, where you can create meetings, points of interest, or tasks. And by now you can also track objects, which then be presented like the two simulated objects here, which can get position updates via the WebSocket. Yeah. Just to show the UI, it looks a little bit like this. When you create a point, you will have a little hovering point here, and you can give it a name and customize the badge with colors and icons and shapes. Save that. Can also give tags to objects. Here we are suggesting some tags we already used in this demo environment. So I just used safety. It's a German tags. And you can also attach things to objects like images, links, or text notes and other objects. So you can directly link objects together. And then you can create that object, get a little success message, and yeah.
Maybe show the search as well.
Oh yeah,
Yeah.
sure. Yeah, it's all about search. So when searching for objects, it's already sorted, like a little bit sorted.
Okay, that's very blurry on.
So you can see the test point I just created on top, because it's most interesting for me at the moment. But I can also search for other objects. For the tracked object, for example, the Gabelstapler, which is the moving one. And you can also search if when you click on the tags, then the tag gets displayed, and you can see all the objects that has that tag. You can remove the tag, and then you see all the other objects. And additionally to that, we have some filters for places and things and people. So I think no one is online at the moment, but you would see that, or sharing their position, you will see that here.
Yeah. Great.
Something for that. Oh, yeah, I forgot the map layers. So if you see that the map is pretty crowded at the moment with all of the content. Therefore, we implemented some filter layers. You can turn on and off the machines, or safety things, or for at least stuff for new members and tasks, and or Feuerlöscher, the Wartung. So you can see you can filter your map content by adding also layers, which is only allowed for admins, which I cannot show right now, but in this environment. But yeah, that's our approach to keep everything clean and to manage content. Yeah, little gimmick, the base layer, you can choose between different map styles. The 3D one from MapLibre is pretty nice. So all of that.
Yeah,
It
so
does mess with Zoom though.
yeah, so thanks.
Yeah.
There's a lot more to this app, obviously. So our goal with this is to kind of be, if Slack and Google Maps had a little baby, this is what you would get, basically. And essentially, we organize content by location, and the central idea is that people kind of know their environment and they can remember where things are spatially. So if you help them out with the visual representation of where things are that they don't know about, like this is all the information that exists in people's heads that is not documented in a typical factory, right? So you just need to know where to go, and you need to ask. And that's kind of the goal with this app, is to get it out of people's heads and onto a map. So with this, so obviously this whole app is written in kotlin-js. It is talking to a Spring Boot based application server, which is of course also written in Kotlin. And it is communicating with that server via a library, which is actually a multi-platform Kotlin library.
Built on top of Ktor.
Built on top of Ktor client. So with that, I'm just going to close, or at least switch back to the presentation. So very brief about our stack. So I mentioned the Fritz2 framework, which is this beautiful logo on the right here. So Holger, maybe you can confirm that we have maybe a few people from the Fritz2 team here as well.
It pretty much looks like it, yeah.
Yeah, I got the vibe that they were planning to, so they're nice for them to be here. So we discovered Fritz2 via this meetup, and that's not the only thing that we got via this meetup. So Nikki over here was introduced to me by Holger a few years ago, and we were at the time looking for interns, and Nikki presented herself, and yeah, it's been great. So amazingly deep knowledge of Kotlin. A lot of the synchronization between the server and the client is built by her. And this thing is currently performing pretty well already. We've had it work with thousands and thousands of objects, and most of these searches are relying heavily on things like coroutines, because there's a lot of traffic happening at the same time, asynchronously, in a single threaded browser application, right? So, and Kotlin coroutines are great for this. Yeah, and we're basically also very efficient about avoiding doing unnecessary fetches and things like that. So basically, our stack, the rest of our stack, so we talked about 3 of those things. The 4th thing is something that we typically run in on customer sites inside the customer network, and that is what we call the formation agent. And this is something that we can connect to IoT installations, so tracking, object tracking, but also backend systems. So we've done SAP integrations, we've done ultra wideband positioning. We are currently exploring a a vibration detecting sensor application, so we can tell whether a machine is on or off. So, and our goal with all of these integrations is to take things that are very niche and then show them on the map in an application that an actual factory worker can use. So with this, I kind of want to switch to our second demo, which is, I debated, like, should we actually show our secret sauce and all the ugliness, right? So it's been a few years, so there's definitely just not all nice and shiny. So we have a little Hello World demo, which we will slowly build out in 6 versions to become a search service that searches recipes. And basically, instead of just showing you a UI, I kind of wanted to have a proper full stack approach here. So we are also going to show you how to structure your application properly, how to integrate JavaScript libraries, how to add a little multi-platform library, and yeah, it all comes together in the end. So let's first look at the IDE. So instead of doing live coding, which I'm very bad at, and there's another reason why I don't want to do this is that kotlin-js is great, but one of the things that is not so great is its performance, especially on this laptop. So whenever I change something, it will recompile and it will happily take 40, 60 seconds easily. So that is not something I want to demo. So what we have here is essentially the whole demo is already up and running, but I just used a little router here, which is a bit of Fritz2 stuff. So how does Fritz2 work? It works like most single-page applications, so it renders itself to an element in the DOM tree. So we dig in here, there's an index HTML, which has a target div. And right after that, it loads something called UI.js, which is the minified and compiled code base. So everything basically. And the way Fritz2 is structured is that everything happens in a render context. So we have this hi page, which is this thing, which currently says, oh, hi. Yeah, it renders itself to an h1 tag, which is the only thing that's on that page. So, and we show the browser URL, it actually is on the hi page here. I'll show you the next page, which is page 1, which is a prototype for what our recipe search engine should look like. This is slightly more complicated, and basically allows me to kind of show you how wonderful Kotlin is for this stuff, because we have a Kotlin DSL for HTML. And the way that works is, so you have your h1 tag, you have some block, and then you set the text by just using the plus operator. So very basic stuff. If you know your HTML, then this should be standard stuff. So there's an input element, there's a button, and there's an ordered list, which is not ideal for presenting stuff. And that's the whole UI. I on purpose left most of the styling away here. We're going to add some of that back in. And this, by the way, is running on the release candidate of 1.0 for Fritz2, which changed a few things. And the most important thing is their component framework has kind of changed a bit, and their approach to styling as well. So we're going to see some of that in action. So that is the V1 prototype. So if we look at the code, that is essentially this here. So I've neatly organized this into packages. So there's only one file for the V1, and that's this thing. So So the next version is kind of intended to show what happens if we actually start to make this a bit more dynamic, right? So because of course our goal is to talk to the server, fetch the results and show them, which means we need components reacting to network traffic and showing up. So let me actually show you what that looks like. So we need to go to version 2. So now we have slightly better styled. I should add, Jacob bears no responsibility for the styling of this thing. I'm an old school backend developer that's kind of knows enough to be dangerous in a browser, but yeah, it's never going to be pretty when I do UI. And I actually use this as a tool to coerce other people's into sort of fixing my lovely UX. So basically, we can type a search term and then click the button, and it will append it to a list. So we can put some fruits in the list, and that's the whole thing. So how does that work? So probably the most challenging thing when you start doing browser UIs is everything is asynchronous, and you kind of just have to get used to that. And asynchronous in the Kotlin world, of course, means coroutines. And the way Fritz2 works is it has a thing called a store, which basically means that we have, in this app, we have 2 stores. One is modeling what is typed in the search fields. So that's called the search field store, which in this case, I use a singleton object for that. And when you click the search button, there is a search handler, which kicks in and does things. Holger, by the way, is this completely readable for everybody? I just realized I might want to fiddle with the fonts.
How it looks.
Yeah.
But you might want to just scroll in a little bit. I think you can do that by
You can either try the presentation mode.
Yeah.
It has a presentation mode, but that messes with all the UIs, and I never find my way.
Okay, fair enough. Yeah.
You can just do control scroll, but
yeah, you should be able to do just Control+.
I think,
or increase it for everything. Here we go. Even better. But it was viewable.
Everything but that.
Yes.
Awesome.
Editor.
Editor font.
Yeah, I would just want to roll it back first because this will drive me nuts. What was this? 15. And not custom. So apply. Boop. That's better. And then editor.
One below that is font.
Gotcha. Yep. Amazing. JetBrains mono. Yes. So what shall we do here?
That
16 sounds good. Yeah. Great. Also better for me because my eyes are not great. I might need glasses soon. So again, 2 stores. We have a handler. And the interesting thing is there's a thing called a root store, which is kind of the parent class of all stores, and it is essentially a state flow if you know your Kotlin coroutines, which means that you can update the store and react to the changes happening in that store. And that is exactly what Fritz2 does. They actually have a great thing on their website, which I think they showed almost 2 years ago in the first presentation, but essentially things are stored in stores, and then stuff happens and the DOM tree is updated, and stuff happens in the DOM tree because people click stuff, which basically ends up updating a store. So there's like this nice circular reactive thing happening in the browser all the time. So when I click or add something here, so what happens is something is put in the store. That happens in real time. As soon as I click the search button, the handler updates the DOM tree, and that's the whole process. very similar to what React does, very similar to what a lot of other frameworks do. I think the React world went through quite a bit of disruptive revolution on how to represent state. So I don't think there is a final answer on that in that world. But I think, of course, recently we've also had Jetpack Compose and Compose Web, which we've also looked at, which works slightly different, but underlying concepts are not very dissimilar. So moving on, so this is interesting, right? But it still doesn't talk to a network, and and of course we are still using this unordered list. So this is how you react to changes, right? So whenever the result store data changes, and this thing is actually, if you look at it in IntelliJ,
Assuming it doesn't decompile.
yeah, so it's actually a flow. It's literally a state flow, right? So you can just listen to this thing and it will do things. So you basically you render these things, you have your unordered lists. When the list changes, we just render each of them. And this is a stupid for loop. There are better ways to deal with lists in Fritz2 that I'm not using here. And then similarly on the form side, so we have our input field here with some nice styling. So we are actually following the recommendation of the Fritz2 people to use something called, what was it? Tailwind CSS. So which kind of models things like this. So I kind of don't want a lot of string literals all over my code, so I kind of started gathering them in an object so I can reuse them. So basically our input field has a value which is our search field store, which is storing a string. It is of type text, obviously. We have this placeholder called cheese and a label, and when we click the button, the clicks are handled by search field.search, and that is the whole code for this. So that is version 2, so more interesting, but version 3 is where it gets going. So start with this. So basically v3, and I actually said talk to our server, so maybe I should soon introduce the server. So let's do that first. Server is actually already running, so you can see that we ran some queries before we started the meeting. So we have here our server, which is based on Ktor2, which was released a few months ago. We installed a few Ktor modules. Again, probably not going to explain in detail how Ktor works. There are people that have done this better. In my view, a lot of servers in the Kotlin world are kind of working similar. So I mentioned Spring Boot, which has also very similar mode of operation as modes of operation, but you can use it in a way that looks very similar to how you would basically build a Ktor product. It's just more feature rich. So what did we do here? So we installed some content negotiation so we can do things with JSON, and I have my own little customized JSON thing that's pretty prints, so which is nice in the demo. Of course, we needed some course headers because otherwise our browser starts complaining, and we have coin because I'm not a caveman and I use dependency injection. And as I will show you later, we can also do this in the UI because coin is one of the growing number of multi-platform Kotlin libraries. So coin works everywhere. Kotlin works, so which is everywhere. And yeah, we have a thing called the search module, which implements something that I did a few years ago and recently ported to a thing called KT Search. So KT Search is a library that I'm writing a second version of that is close to release that I'm actually presenting next week at the OpenSearch meetup, virtual community meetup. So I will share a link to that as well. But yeah, KT Search is a multi-platform library for talking to OpenSearch and Elasticsearch. And in this case, we are abusing it for indexing a whopping 11 recipes that I grabbed from a GitHub project that was about demoing Elasticsearch. So we have two routes. So the server can say hi. So let's make it say hi. So just so you know that it can say hi. And that didn't work. Nice. We'll figure out why later. So back to the code. So what does it actually do? So our search module has basically its coin, right? So you initialize your components in the order that they meet each other. So we need obviously to talk to Elasticsearch. So we need a thing called a search client, which underneath uses the KTOR client to do the HTTP traffic. With that client, we can inject that in our second component, which is essentially a thing called an index repository, which I'm not going to explain here. And then finally, we use that in a thing called recipe search, which implements a few things, amongst others, a thing called, so we have a little create new index, which I'm not going to show, but here's the key part. It's called search. It takes text, and of course it can do pages of results. So you give it a start and you specify how many results you would want, and then it runs an Elasticsearch query using the Kotlin DSL that is part of my KT search library. So in this case, it does a few variants of text matching against the title. So we have match phrase, match, and we also have a description field that we look in. And then there's an autocomplete variant of that, which does prefix matching. But that's kind of the whole logic. And if you look carefully, we actually just jumped to the third module in this project, which is our library. This is important because this is a multi-platform library. So this code lives in common main, which means it's completely portable. And there is actually no platform-specific code in this library at all, which means that we can actually use this from the user interface as well, and we will later. But we are first going to show you the code for having a server in between, because that's how you would normally do that. So with that, let's quickly show what that looks like. So we are still on version 2, so let's go to version 3. And right now we haven't typed anything yet. So if I click the search button, it will do a search. And actually, let me open the network tab so you can just see that this is not faked. So the network tab open, great. So we do a search. It hits localhost 1990 with our search endpoint. And we got back some JSON. Styling will follow, don't worry. But these are the recipes, so this kind of gives you an impression of the data model that we have. So we have things with the title, the description, and then you have some ingredients and directions that you can follow, and then you end up with a recipe. So we can also, of course, search for something. So if I search for banana, it will find a lot less. So there's 11 recipes in total in this thing. And now there's just one.
21, wasn't it?
11.
Yeah.
I think with rice, there's a whopping 2 or 3 that you can choose from. 3, yes. So vegetable fried rice, black bean and rice enchiladas, and so on. So that is kind of interesting. what I also wanted to show you, so I mentioned that you can have coin in the UI, which I think is something that a lot of particularly JavaScript developers treat as science fiction, right? If you're using Android, people are pretty used to dependency injection. Coin is one of the popular things there. Dagger is the other one. On servers, we've had basically every server framework has some level of dependency injection. I'm used to Spring. You can also use Coin with Ktor, as we just saw. Came across Quarkus some time ago, which has some standardized annotations that I think forgot what that is exactly underneath, but yeah, it works. It's nice, and you structure your codes properly. So let's close a few of these guys so we can focus on what we do. So version 3, talk to our server. What does that do? So, well, I had to do a little hack because I have several versions of this app running in one app. I kind of have to make sure that I only initialize coin once, which means I actually have to stop if it was already running. So that's why this line is here. But normally you start it once and then you use it. So like on our server, we have start coin, we have some modules, which in this case initialize our stores. So our stores are now proper classes, and I'll show them. So they're very similar to what we had in the previous version. So we still have a query tag store, which inherits root store and initializes with the empty string, and that's where our query goes. And then we have a search result store, which starts out nullable, and it's a string currently. We're going to fix that in the next version. And then basically, instead of injecting a lot of things here with get, we kind of figured out that it is actually nice to inject like this with coin, because it just saves a lot of work. And the second advantage that we have here is that in Fritz 2 and a lot of other UI frameworks in the JavaScript world in general, including Compose, I think, components are not classes, they're functions. So how do you construct or inject a dependency in a function? Well, either via the arguments, which is annoying when you call them, or like this.
You don't.
So basically just look them up. And technically what this means, we have one global variable in this system, which is our coin context, but I can live with that. And the other nice thing is that you get nicely decoupled function components that are kind of stateless themselves, right? So there's not a lot going on here. All the state is handled via stores, and all they do is react to state changes in those stores and call handlers when events happen in the DOM tree. In this case, the button still searches, as you would expect. So if we jump to search, what does search do? Well, it constructs a HTTP request. So this is the Fritz 2 nice, friendly way of using basically the fetch API in the browser. So we hit localhost 1990/search with a Q, and then we actually call encode URI component, which, if you know your JavaScript, is the way to do URL encoding in JavaScript. So this is a function that lives in basically that's an external function that comes with the kotlin-js standard library, and that just maps to the browser equivalent. And that's in general how a lot of platform integration works, right? So you have your external functions, which correspond to things in the JavaScript world that just happen to have a nice Kotlin header. There's also a few other ways to do it, which you can learn about in the Kotlin documentation for multi-platform. I deliberately don't want to spend a lot of time on the basics here, because there's a lot of presentations already that do that. Totally possible to interact with JavaScript, not just what comes with the browser, but also NPMs, as I'll show later. as you saw, our full app actually has MapLibre integrated, which is a pretty sophisticated WebGL using JavaScript library that renders maps. And we actually had to write our own type mappings for that, which was a bit sucky, because even though kotlin-js comes with a way to convert TypeScript type mappings, some TypeScripts mappings are just beyond what it can do and handle, and especially there's a few things in the type system in the JavaScript build that just don't cleanly map to anything Kotlin can do. Right now they're working on it, so it's gonna improve, but maybe. But yeah, that's kind of version 3 of the app. So now things are getting better, right? So as a backend Kotlin developer, I'm starting to feel at home. I have components I understand, right? So I have a nice way to structure my code. I can inject things. It's all type safe, and it all works. And when I make a mistake, my IDE will point it out to me. Amazing. This stuff has been completely science fiction for a large part of the development community, and I've been using proper IDEs for the last 20 years-ish. I think Eclipse 2001, 2002-ish, when refactoring stopped being science fiction. That's kind of the way it's done these days, right? So, but yeah, this is still a large part of the world that just uses VI without any support for any of this. So that's version 3. So what's new in version 4? So let's show that. There's basically, of course, the styling improved, because this will not do. And this is kind of the final version of the styling. It's not pretty, but it looks like this. So results are now properly formatted, and we are doing things. And we're still talking to our Ktor server. So basically, let's close all of this again and jump into here. What we did here was integrate our multi-platform library, because kind of, yeah, using a string is nice, but then you might want to pick it apart, right? So we have nice model classes that we built already for the server, so why not reuse those? So how does that work? So we go to our search model. It's still the same as it was. So we have our search result store, which still uses HTTP thing to fetch things, but then when it's done, we get our string body, and then we use something called the default JSON, which is defined in our library as essentially Kotliners serialization running in the browser. So now one of the nice things with Kotliners serialization is that you can have model classes. So in this case, we are reusing our search results, which is a nice data class. And yeah, I think this is where Kotlin is clearly superior over TypeScript, the whole ecosystem there, which is just messy. It's this is just way better. People are fiddling with like this JSON built-in parser thing, picking apart things, but it's essentially an untyped mess. So what is a search result? Well, it's something that tells you how many results there were, and then a list of items. And of course, we're using generic types here. So in this case, we are using a generic serializer that uses the recipe model, which is this thing. And our JavaScript had a few snake cased things, and of course we like camel case in Kotlin, so which is why I have to specify some serial names here. But other than that, this is the entire model. So we have recipes, they have a title, a description, and a list of ingredients, and so on. And some of these things might be nullable, which is another nice feature that Kotlin has in the type system. So that is kind of version 4. The rest is, as I showed, pretty much identical. So we still have a UI, except we have now slightly nicer components that can actually do something with the results. So when our search results store updates, we render the results. We pretty much show how many results there were. And this is actual bug. Nice. So this is not going to show because I'm not doing anything with the string. There should be a little plus sign in front of this. And this is where also I'm going to speed up slightly. So we have a new result component, recipe results component, which renders a single recipe with a link and some bold text and a few other things. V4. So V5, so mentioned that KT Search is actually multi-platform library, so why not use it? So skip the whole server in the middle business. So the thing here is that instead of doing this HTTP thing, it just calls the library, which returns model classes. No need to deserialize anything here. This thing talks to Elasticsearch directly. Looks exactly the same, but if you pay attention to the network tab below, yeah, gotcha. Yeah. So we are, yeah, there we go. So if I click search here, it will hit Elasticsearch directly. So you can see here, I hope you can read this, localhost 9200, that is the standard port of Elasticsearch, and it hits the underscore search with a query from the browser. So, so this is pretty nice if you are into building dashboards or stuff like that. Yeah, you can with Kotlin. So the final version of the app that I wanted to show is this exact same app, but in my native language, which is Dutch. So this is actually a thing that Nikki built for us as well. You know, she's mostly a backend person, Kotlin full stack kind of fits the bill. And yeah, what we did here is localization. So we can switch between English and Dutch dynamically. And this kind of brings together two things. So I came across a nice library for localization a few years ago called Fluent, Project Fluent. Yeah, that's from Mozilla. And it's basically it's a way to do localization in a smart way. So it has some conditional logic that you can use. Things like plural and gender of words or different
loops,
parameters and so on. Yeah, so that's kind of what we use here. And essentially the way that works is pretty straightforward. This is actually a component we just ripped out of our main app because it's kind of nice. So if you look in V6, you will see a few extra packages here, which is one is called Fluent. So we're actually using a thing called Fluentgs, which is a JavaScript library that somebody implemented, which we had to map to Kotlin. So that's what this class is about. So it's,
and of course, Ducat completely failed at it, so I had to fix all of that up manually, which is why we have it in code and not auto-generated.
Yeah, Ducat is the internal code name for the little feature that would convert TypeScript mappings, except I've seen it work with simple libraries, but most more complicated ones you can use it as a nice jumpstart on this stuff. But yeah, you end up writing some mappings. It's not the end of the world. You do it once and then you have to. And the way this works is, so we have a thing called a locale, which in our case is an enum, which has Dutch and English in it. We can switch, and it has a thing called translatables. And then one this is the main thing. So this is a Kotlin class that's essentially switches between translations. And of course, we use stores to keep track of what is the active language, but also the translations themselves live in a store. So if you look at how do we use this, so in the UI, so we have, of course, our nice translation that we can inject because coin. And then we say, instead of title, which is string, we say, well, look up the translation for UI text.title, which is where all our language strings are defined, and render that into this and this.
Show the resources too.
Yeah, we'll do. And then, of course, we have nice fluent definitions, and I can show you some Dutch here. So, and this is an example of injecting a variable. So there's nothing sophisticated here, but yeah, the net result of this is that we can switch languages easily, and it's all dynamic, and the UI re-renders as you click. We actually were looking at this today, and it's like, yeah, this is actually semi-useful. So we are currently extracting this to a separate library, which hopefully in the next week or so we might publish via our GitHub.
The dependency on the root store, there's the main headache for me.
Yes, so there's a few things to sort out, because I mean, it's useful for Fritz too, but it's also useful for other frameworks. And this seems to be like a nice way to do translations. There are also implementations for other languages, including for Java. So one of the options that we might consider is making this a multi-platform localization solution that uses JVM library on the JVM and Fluentgs in the browser. So that's it in terms of all the code I want to show. I have a couple of slides remaining, which we will rush through, and then maybe there's time for questions. So let's start with pros and cons. As I mentioned, we've been doing this since beginning last year, 1.5 year-ish. And we, of course, used Kotlin before that. So on the left side are all the really great benefits that we have, and on the right side there's room for improvement. Let's put it like this. So, of course, we love Kotlin. This is the Kotlin meetup. I'm sure a lot of people here also love Kotlin and might secretly sort of regret that they actually have to do Java instead of Kotlin in their day job, which I think for some people might be a thing. Something happened here. Then, yeah, what else? So we have my observation. If you look at most dependencies in JavaScript application, they're actually pretty light. A few years ago, we had a pretty lightweight React alternative that I think measures something like 2,000 lines of code in JavaScript. It's nothing. Or this is like a very light DOM abstraction. If you start looking at what actually loads when, in terms of third-party dependencies, it's usually not that much. The good news is that there's not a lot that you need to reinvent to make kotlin-js work. So the Fritz2 framework is probably on the heavy side even. So there's a couple others like Compose Web I mentioned. Kvision deserves an honorable mention. 1.5 years ago, when I looked at the space, there was Kvision and Fritz2 were the only proper Kotlin frameworks that work. Compose Web was like a rumor at that time, and of course people actually do React as well, and as well as a few other things I assume. Yeah, and then finally, asynchronous coroutines. Jesus Christ, why do it any other way? The coroutines are amazing for this. Type safety, yes, of course you want that. Having the ability to define Kotlin DSLs for whatever, it's super useful. Having great tools, great libraries, all important. On the right side, there's all the stuff that we run into and deal with every day. So the tool change July 2022 improved. So Kotlin 1.7 came out a couple of weeks ago. Yeah, compiler clearly got faster. a lot of the early compiler bugs that we definitely needed workarounds for seem to have gone away largely. But we've been dealing for the last few years, with frequent change, very massive changes, and just libraries that need to be perfectly aligned with each other. Otherwise, you have bugs. Then, the Webpack, it's kind of a love-hate relationship with this thing. It does useful things, but it's not very fast, and it's also tedious to configure. And the way kotlin-js and Gradle are set up is it depends on Webpack to do a lot of the heavy lifting. There are much in the JavaScript world that seem to be popular, but Webpack is just mainstream. On the plus side, you can tweak it and configure it and control it. Then the bloated binaries, it has to be said. Kotlin 1.7 definitely improved. I think the demo I showed you measures in around 1 megabyte. Our main app is around 9 megabytes. It's starting to add up. It's a lot. The IDE integration and debugging, that's something JetBrains promises is going to improve with upcoming K2 compiler. But the current reality is that it's just both slow and flaky. So it will say, oh my God, everything is broken when it's not, or the opposite, which neither is useful, right? And then there is a thing called source mapping, which Typescript also has, which sometimes works and is useful, but mostly the stack traces are unreadable, and it may or may not work. And then this whole edit, compile, run Webpack, and reload is super slow. A minute is nothing, basically. So that's looking at the future. So it's getting better. So I mentioned the K2 compiler as well as WASM, right? So WASM kind of got silently released with 1.7, and I'm assuming that is slowly going to inch closer to a release. And what that means is we'll have another compiler target for Kotlin that we can run in a browser, but also on other stacks. So edge networking is something that comes up often. There are people doing things on servers with WASM. So all of that's potentially in scope for Kotlin as well. So Webpack Compose, which is the JetBrains API compatible thing with Jetpack Compose on Androids. Kind of starting to work, starting to get usable. I think, Nikki, you did something with that.
I tried it out.
Yeah.
You can do stuff with it. We need to reinvent all the styling from ground up as usual.
Yeah. Compose iOS is kind of the suspiciously missing thing, so missing in action. If they cover iOS, they would have something that works on desktop, mobile, and browser. Be amazing. There are already quite a lot of multi-platform libraries. I have a short list that we're actually using that I'll show in one of the next slides. We had a message here, if you're writing Kotlin libraries, it's actually pretty easy to target multi-platform with some exceptions, of course, but it's like a lot of things that are already multi-platform and a lot more things that could be multi-platform. So Kotlin is coming to more stacks. So key takeaways, it's not just for Android, not just for Spring. So you can do things in the browser. Code sharing is actually nice. We do it. Our API client actually has a lot of logic that we reuse. It has convenience functions that we call instead of messing with serialization and deserialization. We actually use GraphQL in Spring. So a lot of our API traffic is GraphQL, and we have some nice abstractions for that. Same thing, it's early days, so this is definitely cutting edge. It's still pretty sharp and pointy, and you can definitely do some silly things and get
This is not bleeding edge anymore.
Yeah, it's not bleeding edge anymore. Good point, Nikki. I'm not bleeding every day. I would say 1-2 years in the future, this is going to be a very stable and mature platform with which you can target essentially anything. So a lot of links here. Again, special shout out for Fritz 2 people. these guys have taken us on quite a journey, but yeah, even the version we tried out more than 1.5 years ago is actually pretty decent and stable. And yeah, they've improved and added a lot of stuff, and yeah, love working with it. KT Search is the thing that I'm presenting next week at the Open Search meetup. There is a thing called Geo Geometry that is almost 10 years old, started out as a Java library, and these days is a multi-platform Kotlin library that does things like calculate geohashes, do things with polygons and points, and those kind of algorithms. And then there's the wonderful multi-platform libraries that we depend on every day. So Kotliners, serialization, daytime, coroutines, logging, important, works in the browser as well. Coin, I mentioned, and code-test for testing. There's probably a few more that I forgot. And this is the link for the actual demo code if you want to have a go at playing with this. Yeah, then finally, so I mentioned that how we found Nikki. We are, as a startup, starting to grow. We have a bit of revenue coming in the last few months. These two persons here transformed to being proper employees fairly recently. Yeah, we are looking for more people, and we are essentially a Kotlin-only company right now. If this sounds exciting to you and you might want to kind of do something else than yet another boring Spring server or yet another boring Android app, there's more to be done in the Kotlin world, and we are doing it in Berlin. You can reach out to me via Twitter, LinkedIn. I have a globally unique handle. And I think this is where I'm gonna shut up and maybe answer some questions.
All good. It's fine. I didn't do have one was already.
Your sound is breaking up. Sorry.
Yeah, you are breaking up. I can hear you here.
I'm so sorry. Randy, are you still around?
No, it's fine.
I think it's
fine. Okay. Yeah, it's my internet connection. I have no idea what's going on. It is still fast, but I do have these. Anyway, so one question was answered around the source code and where it is. I will put the link into the description as well.
Yeah.
Then coming to the next one from Hamid. Can we use Dagger 2 instead of Coin? I think, Nikki, you addressed this, but do you want to do this on tape?
I think Dagger is JVM only as far as I know.
JVM and Android only targeting.
Yeah. So yes, in Indicator maybe. I don't think kotlin-js will support it. Coin is multi-platform properly, so for most of the features just work.
Yeah,
the problem
with
dependency injection libraries is that they do a lot of magic, but they are very platform dependent now as well. So I think if you want something with as much magic as Dagger 2, you probably need to rebuild it from scratch using the Kotlin compiler plugin stuff. But that is also not stable enough yet, so wait a year or two.
Kotlin compiler plugins are a kind of part of the misery that we experience day to day, because it sounds wonderful, right? We have these plugins that do magic, but it adds to your performance penalty, and you kind of get all these brittle dependencies. As one of the reasons, I actually have an open pull request with Fritz2 to update them to 1.7.10. Both on the ODOS14 branch, which we are for now still stuck with, and release candidate, and they've been super busy. So yeah, but yeah, one of the things in Fritz2 is they have a compiler plugin that implements a feature called lenses, which has to be in lockstep with the KSP compiler plugin from Google. Which so when there's a new Kotlin version, that thing has to be upgraded first before you can update everything else.
Fun. Right. So next one is from Marcel. How easy is it to test a function which has no inputs and thus inject external objects through Coin. Spring moved away from that and prefers constructor params, which is quite simple to write tests for.
So Coin obviously comes with its own functions to set it up in testing. And then you can set up your Coin context with your injected dependencies set up so that they can provide fake data or such. And Coin can be set up differently than we do, where you tell it explicitly what kind of interface you're looking for, and then it looks for that interface and finds either the production version or your testing version. And so it can be done, it will be ugly, but at that point, you probably are already accepting that stuff will be ugly because you can't modify your inputs any other way.
Yeah. Yeah, another limitation, of course, is one of the key differences between the JVM and JavaScript implementation of Kotlin is reflection. Is a thing on the JVM, it just isn't a thing in the JavaScript world. And that's also a blocker if you want to use things like the GraalVM, right? So you have to get rid of a lot of the reflection. What's the latest trend in Spring? Spring Native. What does it do? It gets rid of reflection. That's a good thing. It gets a lot faster. Yeah. But yeah, that's also the key point with Dagger. I suspect depends heavily on reflection. Coin, as it's always all declarative. It just uses the type system in Kotlin. And that's one of the reasons that I actually like it.
It's very clear what it does. You can look into the declarations. It doesn't do any magic. It doesn't do any annotation bullshit unless you want it to.
Mm.
I think there's some optional modules for that, but we're not touching that.
Yeah, great questions.
Yeah, definitely. I just wanted to say that if you stick to this pattern where you put in the stuff via constructor params, this makes it in all scenarios easier to test, because essentially you can then instantiate this thing with whatever you want to put in. If you write your test implementation, or you have something from the dependency injection container, it doesn't matter.
I fully agree. The issue, especially with Kotlin-js in the browser, is the components where we inject stuff are just not classes, so they don't have a constructor, and this creates a problem because I can, of course, constructor inject everything in Coin, and then but then essentially I create a lot of hassle. Okay, how do I get those things passed around, and then it gets ugly pretty quickly.
But yeah, what we could have done for the demo is make an interface for the stores and then implement that interface in the store, and then ask for that interface, and when injecting and when giving it to the Coin module, tell it alongside with giving it the implementation also which interface it should register it as, and then that just works. It's a little bit more brittle at times.
And I'm sure everybody's favorite question at interview time is about the solid principles. They also apply in browsers. My impression, having looked at a lot of ugly JavaScript code in the past, is that a lot of JavaScript developers simply don't get this. Like dependency injection is like science fiction, and they'll just happily mix like, oh, I'm just going to create this thing over here and create it as a global variable, and then before you know it, it's like one spaghetti ball of messy code. So separate your initialization from your logic is a good principle. Whether you're using a framework or not, do it yourself. Dependency injection is actually a thing. Look it up. It's great. I've done it. Works in any language.
Yeah. True words. All right. Next one. Jan Philip asks, can you compare how your stack compares against that of JetBrains Space? As far as I'm concerned, they also use a full stack Kotlin stack, and I'm not quite sure because aren't spaces like these remote IDE thingies?
Yeah, Space has also a server and a client part and all of that, but I'm currently not quite sure what they use. If I recall correctly, they are using their JetBrains Compose stuff.
I would assume so. Yeah, that they're eating their own dog food.
Or something that's also built on Skia, if I recall correctly, from the little bit of glimpses that they shared of their code.
That's used in Compose Desktop Skia.
Yes.
So, yeah.
It would be very helpful if someone could look up their tech stack and we could compare it. But currently, I don't have the ability to look that up or even know where to look.
Yeah, Skia, interesting, is also the library that Google uses in Flutter. So, so it's kind of interesting to see a bit of convergence there.
Well, Skia from JetBrains is kind of just bindings for the Skia
exactly
thing anyways.
Yeah.
So yeah.
Yeah.
Skia with K and Skia with C and so on.
So shout out to JetBrains. Come on here and show us what you do there. You don't have to give away the whole secret sauce, but giving a glimpse seems to be.
My one message to JetBrains would be 2 messages actually. Just figure out iOS and close the loop, right? So we want Kotlin everywhere, not just on desktop, Linux, Android, and the browser, but also iOS. Exactly. I think that they might have some peer pressure from Apple and Google to not do that, but yeah. And then the second message is make it faster, please. I spend so much time waiting for tools to do their thing these days that I kind of miss. My first experience with Java was in late 90s. There was an incremental compiler from IBM that you could download that later became the backbone of Eclipse. It was a batch file. I could incrementally compile my entire software system in under a second on a stupidly old Windows NT machine. With like, I don't even remember how much or little memory it had. Like 1 second, that sounds like science fiction these days, right? So 1 second, nothing happens in 1 second in the JetBrains world.
But to clarify on this, because I would like to avoid any kind of misunderstandings when you say slow, this is towards the development experience, right? So it's as a developer, we have to wait because of the compiler. Once it's compiled, it is not slow, just to make this clear.
It is, no, the app that you saw, I'd say, is on par with other JavaScript apps. We have also not really observed a lot of issues with memory, which has been an issue with other JavaScript frameworks I've used in the past. So it's pretty good. So we've not really seen any memory leaks or browser crashes or any of that. It does use up a lot of space in terms of how large the output is. So that code elimination is improving, but not perfect in the Kotlin world. So they do make an attempt to not include things that you're not using. But yeah, it's of course difficult, especially if you're pulling in dynamic things like JavaScript. Then it's hard to tell what you're using.
Well, half the internet, and the rest is Spring. No, sorry, couldn't resist. Miroslav, you mentioned this takes 40 seconds to compile on change. Why? Is this something that is being addressed? Sounds a bit hard for active development. This somehow goes into the discussion we just had, right?
I have my theories. So definitely the kotlin-js compiler is just taking up a lot of time. And I think
Gradle is not great at caching all of the time.
Yeah, there is
So
definitely, I suspect there's a lot of things that trigger essentially a recompile of the entire system when it, in theory, should be doing things incrementally. So I think that they're just a bit cautious there, but yeah. And of course, if you use compiler plugins that do things in common main, guess what? That kind of invalidates everything else. And most of the Fritz2 code would live in the JS package, which depends on that. So you change something in common main, you have to essentially invalidate a large part of your code base. So
you recompile common main, then it recompiles the front end, and then possibly it also recompiles other things that depend on that, which then the front end depends on again. And
but,
such
yeah,
a
support for Jacob here has been working on a pretty ancient Windows laptop. We have proper laptops on order for the last 3 months now. So there should be some shiny Apple hardware showing up soon. We were promised end of July, which is, I think, right now.
And I can imagine that if you throw enough money on it, you might be able to get a JetBrains Spaces IDE remote machine where it compiles faster. Jan Philip also put in some more questions. So one is, what's the bundle size of an Hello World app on the browser?
Hello
Too
World
big.
is pretty okay. I can show you what the demo size is.
The problem is once you put in serialization or any other bigger or Ktor client or such, you just end up with a lot of code that code elimination does not get rid of properly.
This, by the way, might take a minute. So I just triggered the JS browser production run thing.
Okay. So we suffer together. This is fine.
Yeah. So I'm going to show you how much this demo is. This demo is actually pretty realistic, right? Because I'm actually pulling in a bunch of libraries here. And it's also a bit of code here. So it's not super huge, but it's bigger than Hello World. So Hello World is interesting to know, but if all you're doing is a print line, then yeah, you wouldn't expect more than a few hundred kilobytes. I think last time I checked this was around 900, and I've added a few libraries since then. So it's going to be bigger. It's only been running for 14 seconds, so it's now hitting the Webpack stage of the. So it's actually going pretty okay. Meanwhile, I can navigate to my trusty command line, where I can actually show you. No, not a thing. Distributions.
It's also those are interesting questions.
Are we done yet? No, it's only been a minute, right? So
Well, it's still turning.
yeah,
Give it time.
It will spit out a little distributions library, and then there.
But you can also just look at the distributions folder right now.
No, because it doesn't exist yet.
Ah, right. It cleans itself up beforehand.
No, the normal development server does not use any code there.
Yeah. Okay.
So maybe we can use the time for one of the other questions from Jan Philip, sorry, and he asks, how would something like server-side rendering work?
Exactly the same way as it would with React. So you have full access to all the low-level DOM stuff. So you can just grab a multi-line HTML string and shove it in the DOM node. I've done that. That little, I think it was version 3 of the demo, actually rendered a pretty printed string in a pre-element. That's just by setting text on it. In the same way you can set inner HTML with HTML that you load from a server. In terms of library support, you probably want to use some existing framework for that, probably from the JavaScript world, with or without some Kotlin mappings around that, right? But then essentially works the same way.
I could very well imagine using the HTML DSL on the server to build yourself the website, send it over, and have some magic on the client determine whether to just replace this or replace parts of it.
That's definitely a thing, yes. I think, yeah, so yeah, it should just work. Great design pattern for certain applications, I would say. So.
Excellent. Then Jonas asks, when choosing this tech stack, did you consider how it affects hiring new team members? He's going into, it might be hard to find, even harder to find these devs than we had a slight, let's call it not discussion, but he got some comments from us. But what's your view on it?
Absolutely. So I talked a little bit about taking risks and how I normally would not do that. We were with the backs against the wall, right? 1.5 years ago, our company was financially not great. We needed customers urgently. And I had myself and Jacob and later Nikki to work with. And that was it. There's not going to be any reinforcements for some time to come. And I had to build an app with people that only knew Kotlin. So there's two choices. I'm going to spend the next 6 months training these people how to use TypeScript and React and all that. And I've done that before. I can do it. Or we just say, okay, let's use what we have. This Fritz2 thing didn't look half bad. Proved to be excellent, actually. Like, it was like, this is not even alpha release, right? It's like a 0.11 or something. It was like essentially a glorified prototype / demo that just worked. So we kind of ran with that. I have always had like a healthy awareness of the fact that UI code in any case has a short shelf life. So our code base is now 1.5 years old. I've seen projects replace their code bases sooner. Because back in the day, we started out with Bootstrap, and then Angular came along, and then React came along. That could happen in the space of 18 months. So 18 months is a long time. It's still running, by the way, so it's amazing.
Yeah, I was just I was having a glimpse and I thought, oh boy, 5 minutes of counting. Not too bad.
Yeah, so this is just the reality of tools being not great.
And it is an emergency laptop, to be fair, right? So
it is, yeah. So my Mac died. This is a pretty cheap Samsung Core i5 with Manjaro on it, and I actually love how Linux makes the most of this thing. But yeah, clearly this is not something it's very good at. So right now, it doesn't help that we're doing this Zoom call.
Yeah. So this is where you actually see the difference between a i5, i7, i9 and memory. Anyway, so then we have another question from Ad. I hope I pronounced this correctly. Does your demo example contains tests for Kto server with coin and JUnit 5?
I say none whatsoever. So I did not spend a lot of time on testing. So you have to imagine I had to scramble to get the demo together in literally over the weekend.
All good. No, it's because he's going into the reason of his question, which is I was trying, but I got coin application not started and coin application already started errors. So maybe if it's not in there, so maybe you've seen this.
Yes, and there might be a fix that we just haven't pushed yet because the routing that this app has that was literally added, I think 1 hour and 15 minutes before the presentation started. So until then, it was like my plan was I'm just gonna comment out lines, and then I realized every time I do this, I'm gonna have to wait like a minute.
YOLO.
But the workaround is pretty straightforward. You just let's see.
Starting from V4, I think.
Yeah, so if you take V5, so the first thing it does is a global context stop coin, and then it starts it again. So that works.
Coin just doesn't like being started multiple times, and we have it started multiple times in each of the blocks to use different modules, and it's unhappy about it.
Yeah, normally you would not do this, right? So you would only start it once. And,
I smell the reason for the errors he sees in the tests. So you might want to try a global stop, a stop on your test cases before you go into starting it again and setting it up. Yeah, exactly.
There is on the Coin homepage, they actually talk about how to set up Coin for testing properly, because there is stuff that it can do specifically better for that.
Awesome.
Yeah.
Great.
Yeah.
Yeah. Okay. Yeah. It should do this. Yeah. Okay. Fair enough. So maybe this might be something you wanna. You might want to raise this with the coin team and see if they can go into this, because this looks like a some kind of edge case you hit there. But yeah. Okay. Until then, maybe it helps to do manually leave for now. Come again.
Point on the Slack channel and such. Harass them there.
Even better. Awesome. So I think
it's
with questions. Come again.
Yeah.
Cool. Thank you so much, guys. It was amazing. It was great to see, and it's always lovely to see not only a not Android-centric Kotlin talk, but having one with the whole layers in Kotlin. Excellent. Cool.
I think we might have missed one question from Devtator about how have we already started using the new components for Fritz 2 from RC1?
No, so literally this demo is my first experience with Kotlin components. I actually had some issues figuring out the input select, which is why the language selector is 2 buttons instead of a drop down as it should be. That's just me. That's like me late Sunday evening, like, okay, fuck it, I just need 2 buttons here. That's good enough for now. I think the input field is actually one of the headless components that we styled. Our main app is very dependent on the 0.14 branch. We've kind of estimated that we probably need a few weeks to transition that and restyle everything and test it. So, and that's something we're gonna do, but just not right exactly now. We actually had a very stressful last few weeks because we launched our very first big customer 2 weeks ago. And yeah, so right now the priority is just dealing with that and fixing bugs and all the rest. So
making sure they stay happy.
So not a great time to switch to a new version of a UI that requires a massive update. Yeah.
Come on, what can possibly go wrong?
I've done worse. So yeah.
Okay. We should do a the top 10 worst things to do. Excellent.
Yes.
Thanks for the answer. Thanks for the talk. Yes. Cool. So, folks, I think it's definitely time to put everything together, have another beer, and end the call, unless someone else has a question. Speak now. Yeah. Okay. So now the thanks and the nice presentation comes in. It was a nice presentation. It's really amazing to see. And yeah, so as always, folks, if you have any questions, you will find most of us, not all of us, on the Kotlin Slack channel. Ping us there. You're more than welcome. The link to the Slack organization is in the description already. I will bother the guys for the links to put them into the description as well later on. And yeah, join us again. I hope to have, or we hope to have, a session in August or September again. So fingers crossed it's August. And yeah, till then, have a lovely day and enjoy the summer.
Yeah, great. Maybe we can meet up in real life in person for one of the next meetups, right? So
good point. Actually, we will try to make this happen. It's currently a bit tricky when it comes to the locations because of COVID restrictions still being in place internally and things. So we are on it. We try to have meetups in Berlin, and we will put this onto the meetup pages when possible of the Berlin Kotlin meetup page. And yes, there it is. 2.16 megabytes. This is quite a baby. Okay, cool. Right. Okay. With this jolly note, have a lovely evening, folks.